Cloud infrastructure is designed to be invisible. When it works, no one thinks about it. Applications load, dashboards update. Costs appear exactly where they should. But when something breaks inside the cloud, the problem rarely begins where people expect. Sometimes the failure starts with a single change. One command, one permission, one automated action. And suddenly, systems that normally operate quietly in the background become visible to everyone. This case begins with a disruption reported to last roughly 13 hours. The affected service was related to cloud cost visibility, a system used by organizations to track how much their infrastructure is spending in real time. For engineering teams, this information is not just accounting. It is operational awareness. When costs spike unexpectedly, it often signals a deeper infrastructure event. When cost visibility disappears, teams lose one of their early warning systems. Reports describe the issue as affecting a customer-facing system connected to cost management. The incident was limited in scope, but the discussion that followed was far larger than the outage itself. Because the real question was not simply what went down. The real question was how the change happened. One explanation suggested that an internal automated tool was involved. In this version of events, an agent-style system was allowed to execute changes in the environment. The environment was deleted and rebuilt. In cloud infrastructure, those operations are powerful. Rebuilding systems can solve problems quickly. But rebuilding systems can also erase the state that other services depend on. Another explanation disputed this interpretation. According to that view, the incident was not caused by autonomous AI behavior. Instead, it was the result of user error, a configuration mistake, an access control problem. In other words, not an intelligent system acting independently, but a human misconfiguration interacting with automation. These two explanations sound very different, but they lead to the same technical lesson. In cloud systems, permissions define reality. Every tool operates inside a boundary. Permissions define that boundary. They decide what resources a process can read, what systems it can modify, and what infrastructure it can delete. Automation itself is not dangerous. Automation simply moves faster than humans. If permissions are narrow, automation accelerates safe work. If permissions are broad, automation accelerates mistakes. This is why mature infrastructure teams design systems around the idea of blast radius. Blast radius is the potential damage a single action can cause. When permissions are tightly scoped, the blast radius is small. When permissions are broad, the blast radius expands. To control this risk, engineering teams build several layers of protection. The first layer is least privilege. A tool receives only the permissions required for a specific task. Nothing more. The second layer is approval. Destructive actions require a second set of eyes. A pause between intention and execution. The third layer is rollback. Because even good changes fail. Rollback allows systems to recover quickly when the unexpected happens. And finally, there are guardrails. Guardrails assume mistakes will occur. Instead of trying to eliminate errors entirely, they limit the damage those errors can cause. These controls are rarely visible to users, but they are the difference between a small incident and a system-wide outage. That is why incidents like this attract attention. Not because the downtime is always massive, but because the mechanisms behind the failure reveal how the system is designed. Cloud platforms are not just infrastructure. They are governance systems. They define who can change what, and how those changes propagate across thousands of servers. When those boundaries weaken, the entire system becomes more fragile. This case does not prove that artificial intelligence caused the failure, but it does highlight something deeper. Automation without strict boundaries becomes unpredictable, and in modern cloud infrastructure, boundaries are the product.